Chalo. So let's start with a new unit of machine learning. This is called dimensionality reduction. Okay. Now the first thing that should come to one's mind is when the term dimensionality reduction comes in, is basically overfitting. Why the hell would you require to reduce the dimensionality of a data set if it is if there's no problem? The only problem that arises that needs dimensionality reduction is overfitting. Okay, so this is what is gonna be happening in this whole chapter, I guess. How we reduce dimensionality, different approaches to reduce dimensionality, and what are the feature selection that we use. Okay, so let's just start rolling with the PPT. Dimensionality reduction in machine learning classification problems. In machine learning classification problems come okay. There are often too many factors on the basis of which the final classification is done. ये तो अपने देखा when you're making a classification of any sort, ठीक है, there are too many factors on the basis of which the classification is being done. ठीक है, now factors का जो scale वो है ना, fidelity or whatever, it is very variable upon how you're training the model. Many factors can help, but less factors cannot help either. So there is like this one sweet spot, and to achieve that sweet spot you need to do dimensionality reduction. तो अपन फैक्टर्स कम कर सकते हैं. ठीक है, मैं नहीं बोल रहा कि बहुत ज़्यादा फैक्टर्स है तो अच्छा चलेगा मॉडल. इट विल ऑब्वियसली नॉट फंक्शनल बिकॉज ओवर फिटिंग कैन ऑल्सो अराइज, बट अ डिसेंट नंबर ऑफ फैक्टर्स इज important. These factors are basically variables called features. ठीक है, these factors are basically variables called features. The higher number of features, the harder it gets to visualize the training set and then work on it. The higher the number of features, the harder it gets to visualize the training set. ठीक है, ये भी समझा. Higher the number of features, harder it gets for us to visualize the training set and then work on it. Sometimes most of these features are correlated, hence redundant. Let's say there is a data set to recognize a human. ठीक है, there is a parameter called height in centimeter, and there is another parameter which is called tallness. Basically they are trying to mean the same. Like if you're training a model, that would basically result in the same thing. You could have the height feature only and remove the tallness feature completely. तो here we are dealing with redundant data. ठीक है, ऐसे केसेस में अपन redundant पैरामीटर्स को अवॉइड कर सकते हैं, redundant फीचर्स को निकाल सकते हैं. तो बेसिकली अपना ट्रेनिंग फीचर सेट भी छोटा हो जाएगा एंड अपन ओवर फिटिंग या डिमेंशनलिटी रिडक्शन अचीव कर लेंगे, ओवर फिटिंग निकाल देंगे. सॉरी, दिस इज व्हाट द आइडिया इज. ओके, there is this is where dimensionality reduction comes into play, where there is redundant data or higher number of features. Dimensionality reduction is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. Now random variables क्या होगा इस केस में? Suppose you are trying to figure out if uh, if an object is a ball or a not. So how is the color of the sky important in the data set? रैंडम फीचर हो गया ना, मेरे को बॉल फिगर आउट करना है कि ये चीज़ बॉल है या नहीं. कलर ऑफ द स्काई कुछ भी होगा, मेरे को क्या ही फर्क पड़ेगा उस इमेज में से. दैट इज व्हाट इज अ रैंडम फीचर. इट कैन बी डिवाइडेड इनटू फीचर सिलेक्शन एंड फीचर एक्सट्रैक्शन. फीचर सिलेक्शन एंड फीचर एक्सट्रैक्शन, दैट इज व्हाट वी विल सी नाउ आई गेस. फीचर सिलेक्शन एंड फीचर सेलेक्ट कर सकते हैं, देन यू कैन एक्सट्रैक्ट इन्फॉर्मेशन. आई गेस आई डू नॉट अंडरस्टैंड दैट पॉइंट राइट नाउ. Dimension reduction. It is a process of converting a data set having vast dimensions into a data set with lesser dimensions. Dimensionality reduction and dimension reduction is the process of converting a data set having vast dimensions. Okay, so here we get a definition. It is the process of converting a data set having vast dimensions to the data set with lesser dimensions. This is the definition. ठीक है, it ensures that the converted data set conveys similar information concisely. वही ना, the converted data set, like this the final data set, should be able to convey similar information. अगर ये इंसान है, so the converted data set should also be able to convey कि ये इंसान है. ठीक है, दो द फीचर्स में भी लेस, इधर हैंड्स नहीं है, इधर आइज थे, इधर आइज नहीं है, बट अनलेस our object का model का goal was to understand if it is a human or not, and it is being able to do that via the converted data set के features, तब तक कोई problem नहीं होना चाहिए. Dimensionality reduction technique can be defined as it is a way of converting the higher dimension data set into a lesser dimension data set, ensuring that it provides similar information. Okay, so this is the definition. This is the final definition. Dimensionality reduction, it is a way of converting the higher dimensions data set into lesser dimension data set, ensuring that it provides similar information. It is a way of converting higher dimension dataset into a lesser dimension dataset, ensuring that it provides similar information. So sorry, I'll just make this one change. ठीक है. Now once you have understood this, we can move on to the next part. For obtaining a better fit predictive model while solving the classification and regression problems. So why is dimensionality reduction being used? To obtain a better fit predictive model while solving the classification and regression problems. It is commonly used in fields that deal with high dimensionality data, such as speech recognition, signal processing, bioinformatics, etc. It can also be used for data visualization, noise reduction, cluster analysis. ठीक है, इधर अपन समझ गए कहाँ कहाँ यूज़ हो सकता है. स्पीच रिकग्निशन के लिए, सिग्नल प्रोसेसिंग के लिए, बायोइन्फॉर्मेटिक्स के लिए, डेटा विजुलाइजेशन, नॉइस रिडक्शन, क्लस्टर एनालिसिस, ये सब के लिए. Once that is understood, we can move to the next slide. भाई next slide आ जा. Dimension reduction. Dimension reduction क्या बोल रहा है? It is saying that there are two techniques to reduce dimensionality. ठीक है? There are two techniques to reduce dimensionality: feature selection and dimensionality reduction. ठीक है, ठीक है. dimensionality reduction टेक्निक में फीचर सिलेक्शन है, सिम मिसिंग वैल्यू रेशियो है, लो वेरिएंस फिल्टर है, हाई कोरिलेशन फिल्टर है, रैंडम फॉरेस्ट है. ओ ये सब आता है अपने को. मिसिंग वैल्यू रेशियो है, लो वेरिएंस फिल्टर है, और हाई कोरिलेशन फिल्टर है. रैंडम फॉरेस्ट तो आता ही है. बैकवर्ड फीचर एक्सट्रैक्शन है, फॉरवर्ड फीचर सिलेक्शन. ओके, बाकी दो वेज ऑफ dimensionality reduction is component factor basis, factor analysis, principal component analysis, independent component analysis. प्रोजेक्ट बेस्ड में आइसोमैप, TSNE, यूमैप. ये अपन देखेंगे आगे क्या है ये सब. ये नहीं है तो बस फील लर्न द डायग्राम ओनली. Approaches of dimension reduction. There are two ways to apply dimension reduction technique, which are given below. First is feature selection. Feature selection is the process of selecting the subset of relevant features and leaving out the irrelevant features. ये अपन को पता है. Feature selection is the process of selecting the subset of the relevant feature. Basically क्या बोल रहा है कि you select the relevant feature. पेन आ जाए यार, हाइलाइटर भी चले. Feature selection is the process of selecting the subset of relevant features and leaving out irrelevant features in a dataset to build a model of high accuracy. In other words, it is a way of selecting the optimal features from the input dataset. यही important है. Selecting the optimal features from the input dataset. Feature selection अभी अपन आँख बंद करके बोलता है. Feature selection is the process of selecting the subset of relevant data features and leaving out the unnecessary or irrelevant features present in the data set. This is done to build a high accuracy model. In other words, it is a way of selecting the optimal features from the input data set. Last में तो I read only. Okay. ठीक है. Feature extraction. Feature extraction is the process of transforming the space containing many dimensions into space with fewer dimensions. क्या बोल रहा है? Feature extraction is the process of transforming the space containing many dimensions into space with fewer dimensions. This approach is useful when we want to keep the whole information but fewer resources while processing the information. Feature extraction is the process of transforming the space containing many dimensions into space with fewer dimensions. तो feature selection क्या हुआ? Feature selection अभी अपना ये data set था, ठीक है, with multiple features. तो अपन ने थोड़े बहुत फीचर्स को एलिमिनेट कर दिया कि ये नहीं चाहिए, ये नहीं चाहिए, ठीक है, और ये नहीं चाहिए. नाउ वी ऑल्सो हैव रोज. व्हाट डज फीचर एक्सट्रैक्शन डू? वी कैन एलिमिनेट रोज ऑल्सो, कि सिर्फ ये रो चाहिए और ये रो चाहिए, ठीक है. दैट इज़ व्हाट फीचर एक्सट्रैक्शन इज. इंटरेस्टिंग. वंस दैट इज डन, feature extraction process of transforming the space containing many dimensions into space with fewer dimensions. Containing dimension into space with fewer dimensions. Okay. This approach is useful when we want to keep the whole information but use fewer resources while processing the information. With this being done, feature selection. Three methods are used for feature selection. First is filter methods. In this method, the dataset is filtered and the subset that contains only the relevant features is taken. Some common techniques of filtrations are correlation, chi-square test, ANOVA, information gain. ठीक है. Filter method में dataset is filtered and subset that contains only the relevant features is taken. Some common techniques are correlation, chi-square test, ANOVA, information gain etc. ठीक है. अभी एक बार नेक्स्ट स्लाइड पे जाता है. फीचर सिलेक्शन. फीचर सिलेक्शन में क्या है? दो रैपर मेथड्स हैं. द रैपर मेथड हैज़ द सेम गोल एज द फिल्टर मेथड. ठीक है. द रैपर मेथड हैज़ द सेम गोल एज द फिल्टर मेथड, but it takes a machine learning model for its evaluation. In this method, some features are fed to the ML model and the performance is evaluated. The performance decides whether to add those features or remove to increase the accuracy of the model. Wow! That is insane, bro. ठीक है, so I'll explain. Wrapper methods has the same goal as filter method. कि अपन को filter method का goal क्या था? That a subset that only contains relevant feature. ठीक है. Wrapper method का भी goal same है. To create a subset of the main data set that only contains the relevant features to train the model. But it takes a machine learning approach for its evaluation. इधर तो अपन निकाल रहे थे फीचर्स रैंडमली या जो भी मेथड्स है, कोरिलेशन, ची स्क्वायर, ANOVA जो भी है, ठीक है, इन्फॉर्मेशन गेन. बट हियर रैपर्स में वी यूज़ द मशीन लर्निंग मॉडल टू टेस्ट कि अपन ने जो फीचर्स अभी रखे सबसेट में, आर दे हेल्पिंग टू गेट बेटर एक्यूरेसी और नॉट टू द मॉडल. This method is more accurate than filtering method but complex to work. Obviously there will be many iterations कि ये वाला subset is better than that or not. Some common techniques of wrapper methods are forward selection, backward selection, bidirectional elimination. Forward selection है, backward selection है, bidirectional elimination है. ठीक है. Embedded methods. Embedded methods check the different training iterations of the machine learning model and evaluate the importance of each feature. Embedded methods check the different training iterations of the machine learning model and evaluate the importance of each feature. Some common techniques of embedded methods are lasso, elastic net, ridge regression. Basically क्या कर रहा है अपन, चेक कर रहे हैं डिफरेंट ट्रेनिंग आइट्रेशंस ऑफ द मशीन. अपन मल्टीपल मशीन लर्निंग मॉडल ट्रेन कर रहा है, बट देन वी आर चेकिंग कि ये मशीन मॉडल में जो फीचर लिया था, इज इट हेल्पिंग इन बेटर एक्यूरेसी और नॉट. ठीक है. दिस आई बिलीव इज अ टाइम कंज्यूमिंग प्रोसेस. ठीक है. फीचर एक्सट्रैक्शन. सम कॉमन फीचर एक्सट्रैक्शन टेक्निक्स आर प्रिंसिपल कंपोनेंट एनालिसिस, लीनियर कंपोनेंट एनालिसिस, लीनियर कर्नल PCA, क्वाड्रेटिक डिस्क्रिमिनेशन एनालिसिस. तो क्या बोल रहे हैं अपन? प्रिंसिपल कंपोनेंट एनालिसिस, लीनियर डिस्क्रिमिनेशन. फीचर एक्सट्रैक्शन के टेक्निक्स है बेसिकली है प्रिंसिपल पीसी है, एलडी है, कर्नल पीसी है, क्यूडी है, क्वाड्रेटिक डिस्क्रिमिनेंट एनालिसिस। तो ये तो याद रखना पड़ेगा। एग्जाम्पल, कंसिडर द फॉलोइंग एग्जाम्पल। वाह, the following graph shows two dimensions x1 and x2. x1 represents the measure of several objects in centimeters, x2 represents the measurement of several objects in inches. ठीक है, ये important लग रहा है। उससे कौन explain something, some principle to us। अपन ने उनको प्लॉट कर दिया, x1 इज सेंटीमीटर में, x2 इज इंचेस में। ठीक है, इन मशीन लर्निंग यूजिंग बोथ दीज डिमेंशंस कन्वे सिमिलर इन्फॉर्मेशन। ऑब्वियसली वही तो मैं बोला था, हाइट और टॉलनेस में इंचेस में लो सेंटीमीटर, इन्फॉर्मेशन तो सिमिलर है ना। ऑल्सो दे इंट्रोड्यूस अ लॉट ऑफ नॉइज इन द सिस्टम, सो इट इज बेटर टू जस्ट यूज वन डिमेंशन। Using dimension reduction, we convert the dimension of data from two dimension x1 and x2 to one dimension z1. It makes the data relevantly easier to explain, understandable. Benefits: dimension reduction offers several benefits such as it compresses the data and thus reduces the storage space requirements. It reduces the time required for computation since less dimension require less computation. ठीक है, benefits में क्या है? Dimension reduction offers several benefits such as it compresses the data and thus reduces the storage space requirements. Compresses data and thus reduces the storage space requirements. It reduces the time required for computation since less dimensions require less computation. So it compresses the data and thus reduces the storage space. It requires the time. Why? The formatting is so messed up here. इसका formatting ठीक करता है। कौन सी स्लाइड पे थे? हाँ, बराबर, इसको निकाल। First, it compresses the data and thus reduces the storage space requirements. It reduces the time required for computation and less dimensions require less computation. It eliminates the redundant features. It improves the model performance. Principal component analysis (PCA). Principal component analysis is a well-known dimension reduction technique. It transforms the variables into a new set of variables called principal components. Principal components till now we understand कि अगर दो फीचर्स को कंबाइन करके एक नया फीचर बन रहा है उसको अपन प्रिंसिपल या इंपॉर्टेंट कंपोनेंट बोल सकते हैं, विच इज मोर वैल्यूएबल इन इन्फॉर्मेशन गेन दैन द अदर कंपोनेंट्स। These principal components are linear combination of original value variables and are orthogonal. Orthogonal भी क्या होता है देखना पड़ेगा। Let's just do a quick Google search of what is orthogonal. इधर ही देख लेते हैं। Involving right angles and right angles. Original linear combination of original variables and orthogonal भी देखना पड़ेगा, it is not matching. The first principal component accounts for most of the possible variation of the original data. First one accounts for most of the possible variation in the original data. Second principal component does its best to capture the variance in the data. There can be only two principal components for two-dimensional data set. Possible variation of original data, capture the variance is the second principle. Okay, understood. PCA algorithm. Algorithm अभी this is numerical. ठीक है, numerical तो अपन अलग से करेंगे. So let's just go over through the PPT एक बार. Dimensionality reduction. Slide. In the machine learning there are often too many factors. अब ये तो पूरा factor reduction पर है. ठीक है, actually पूरा PPT उसके ऊपर है. These are techniques. Feature selection समझा था. Feature selection is reducing the number of column. Feature extraction is उन columns में से कौन सा rows important है, fewer dimensions लेता है. Feature selection methods में filter methods है. Filter methods में अपन subset को remove करते हैं. We create a new subset from the main data set. ठीक है, data set को filter करके correlation, chi-square test, ANOVA, information gain. We wrapper methods. The wrapper methods may be the goal is the same as filter method, but it takes a machine learning model for the evaluation. Some features are fed to the ML model and evaluate the performance. Then those features are rejected if the accuracy is not improving, and only the features which help in increasing the accuracy are kept. Forward selection, backward selection, bi-directional elimination. Forward, backward, bi-directional. Simple है. Embedded methods में क्या है? Check training iterations or check the different training iterations of machine learning model, evaluate the importance of each feature. तो अपन मशीन लर्निंग मॉडल को जब ट्रेन करते हैं अपन ट्रेनिंग iterations चेक करते हैं and we check if the accuracy is improving or decreasing depending on the feature set. Lasso, elastic net है, ridge regression है. Feature extraction. Some feature extraction techniques are PCA, LDA, kernel PCA, QDA. Principal component analysis, linear discriminant analysis, kernel PCA, quadratic discriminant analysis. अभी ये तो एग्जाम्पल है. इंच और सेंटीमीटर दिया, दोनों मीन द सेम, तो एक ही रखो Z1. दैट इज अ प्रिंसिपल कंपोनेंट नाउ. बेनिफिट्स क्या है? कंप्रेस डेटा एंड thus reduces the storage space कम हो गया. Reduces the time required to compute, eliminates redundant features, improves the model performance by improving the accuracy. Yeah, faster, it makes it faster because I have less features to deal with. Principal component analysis is well known dimension reduction technique. It is a well known dimension reduction technique. अपन ऐसा ऐसा सब है ना, तो अपन क्लास में पढ़ने का भी है इसको वापस. It transforms variables into a new data set of variables called principal components. Transforms variables into new set of variables. बहुत ज़्यादा बोल्ड हो गया. Principal components में ट्रांसफॉर्म कर देते हैं अपन. These principal components are linear combination of original variables and are orthogonal. Linear combination of original variables. Linear combination of original variables. The first principal component and accounts for most possible variation of original data. Variation is the keyword. Variation is the keyword. Second principal component does its best to capture the variance in the data. There can be only two principal components for two-dimensional data set. ठीक है? That is what it is. Dimensionality reduction. अभी ये बात का देखिए क्या. Algorithm numerical कैसे करें.